Hi guys. So today our lecture is going to be on the interprocess communication, so which includes the event semaphores and the mailboxes. Okay. So as I have already mentioned in my previous lectures, so before you start with the system Verilog concepts, you have to be thorough with the Verilog concepts, as the events are bought from the Verilog itself, and they have been made some enhancements to the events in system Verilog, as they have been bought from the Verilog. So it's good to have an idea on what are events and where are they used, at what place they are being used. Okay, so try to have knowledge on events before you get into the system Verilog events. Okay, so and if you're having any queries on the Verilog concepts, so you can directly ping me, as I've already mentioned my contact number as well. So you can directly ping me on WhatsApp. That is my WhatsApp number. Okay, so and few people have been already have been consulting me regarding the job opportunities, or into which domain they have to go, either front end of VLSA or back end of VLSA, or which could be a better option for them in future. So I've been discussing with them. So it was a great time for me to talk to them, because they have been following my channel and they have approached me, and I was happy for that. And there have been many views been coming to my videos also, but most of I have got only few calls. But however, who have the other people who have already seen my videos, so if they are not approaching me, I take them as they have understood all the videos, and they have been approaching on their own. So it's also a good thing if they are able to choose everything on their own. Okay, so always you're welcome, guys, and always your advices are also welcome. And yeah, so try to follow my channel, and you can ping me directly whenever you have any queries, and when I'm free, I'll be answering to you. I'll make time to answer you as well. Okay, so let's start with the interprocess communication, the event semaphores and mailboxes. So this I'll be discussing the events today, and the semaphores and mailboxes I'll be discussing in the later sessions, because they are again the other concepts which should be discussed only after when after I discuss you the system Verilog TB architecture. So I'll be discussing the TB architecture as well, the SV TB architecture. So once I complete the TB architecture, I'll be going through the concepts that require that are included in the TB architecture. Okay, so let's start with the events and complete them first. So here are the differences. We could see the difference right now here. So coming to events, so different threads synchronize with each other via the event handles in a test bench. Okay, so for example, you have two threads. It may be a procedural block like initial block, or an always block. So when you need a synchronization between these two threads, so you can make use of the events. So we'll be seeing some examples as well in the coming slides. Okay, so coming to semaphores, different threads might need to access the same resource. They take turns by using a semaphore. So all the three types, the event semaphores and mailboxes, are used for synchronization purpose only, but the way the place we use them will be differs. Okay, so events we have seen the definition now. So coming to semaphores, so it is telling that different threads might need to access the same resource. They take turns by using a semaphore. So for example, you have a bus, you have an interface, or any protocol bus. Okay, so here when there are two processes, they require the access of the bus at the same time. Okay, so for example, you have two IPs or two blocks. Okay, but you have only one peripheral bus. Okay, but both A and B blocks wanted the access of this bus at the same time. So this may not be possible with respect to some protocols, right? So this is where we make use of semaphores. Okay, so I'll tell you these in detail when we go to the semaphores. Okay, coming to mailbox, the threads or the components need to exchange the data with each other, and the data is put in the mailbox and sent. So mailbox is nothing but like a it's like a post. Okay, so when you give something to a postman, he go and delivers it to a destination, right, to the end destination. So that is what it is telling. So whatever it may be, a thread or a component, it may be a process or a component, needs to exchange data with each other. So the data is put into a mailbox and sent. And the receiver is going to take the sent data from the mailbox itself. Okay, there are few methods like put and get to take to put and get from the mailboxes. So we will discuss all these. There are blocking and non-blocking as well. So we will be discussing everything in detail when we go to that particular concept of mailbox. Okay, so as of now, to this lecture, let's be confined to events only. Okay, so I just want you to know the difference between all the three, because all the three are implemented for the same synchronization purpose, but the way you use them, the place we use them differs. So I just want you to make sure that all the three are different from each other. Okay, so we will discuss the events now. So this is how we create an event. So we have the event variable, event data type, and the event variable, event A. So we can wait for the events to be triggered by using @of event A or event A dot triggered, and we can trigger the event by using the arrow mark, the single arrow mark or the double arrow mark operators. Okay, this is how we create, we trigger, and we wait for the events. Okay, so coming to the example, we have the module TV top and an event being declared here, and in an initial block we have the fork join block, and in the fork join block we have the wait for trigger of event A, and after 5 in the next line we have after 5 nanoseconds the event being triggered. So in a fork join block, as we have already know, I think I have been not discussing the fork join blocks, right? Okay, so okay, I'll take it in the next session. So fork join, so for example, you may be aware of the begin end blocks, right? So begin end block, so inside a begin end block all are sequential. So when you write a 5 line of code in your begin end, so every line executes sequentially. Okay, so but coming to a fork join block, they act parallelly. Okay, you, for suppose you have a 3 line of code, all the 3 lines will be executing parallelly but not sequentially. Okay, this is the main difference between the begin and fork join block. So have this concept in your mind, so that coming in the next lectures we'll be discussing deep into the fork join and the types of fork join blocks. Okay, so yeah, so we have 2 lines here which will be acting parallelly. So those two are, the first line is the wait for trigger, and the next line is after 5 time units we are triggering the event A, and we have a task outside that is wait for trigger. So the wait for trigger task is going to accept some arguments of event, and inside the task we are displaying first time is the wait for the event to be triggered, and then you are waiting for the event to be triggered, and then you have a display statement again over here. So in the initial begin and block, in the initial fork join block, we have the wait for trigger, which is nothing but the task that is being declared outside. Okay, so you are calling this task, but when you call this task here, the first display is going to be displayed, which is the which one, the waiting for the event here to be triggered. This display statement is there, right? So that is going to be displayed, but your wait of event A dot trigger is not going to be displayed. I mean, it's not going to be executed until and unless your event A is being triggered. So you have the hash 5 nanoseconds, right? So hash 5, you're triggering the event. So until this event is triggered, the the display statement, the second display statement is not going to be executed. Okay, because you have given a statement of wait of event dot triggered. So wait of event dot triggered. So you're waiting for this event to be triggered. Okay, so since you're waiting for this event to be triggered, this wait statement is going to be we're waiting for this event to be triggered, but when this is going to be triggered, only after 5 nanoseconds. So only after 5 nanoseconds your second display statement is going to be executed. Okay, so this is how a synchronization happens between two blocks. Okay, I mean two processes. So coming to the description, we have, they can be assigned or compared to other event variables. Okay, and it can be assigned to a null. Events can be assigned to null, and they can be compared with the other event variables as well. And when assigned to another event, both variable points to same synchronization object. So what it is telling, when they assign to the another event, so when one event is being assigned to the another event, both variables point to the same synchronization object. For example, when there are two events like A and B, when A is equal to B, so you are assigning A value to B, right? So you have only event B here, you don't have event A after this statement. Okay, so that is what this line is telling. So when an assignment of one event is assigned to another event, both variables point to the same synchronization object, and the events can be passed to queues, functions, tasks. As we have already seen now, here an event is being passed to the task as an argument. Okay, so coming to the triggering of events. So here, as I have already mentioned in the first slide, we can trigger the events in two ways. One is at the rate triggered, or by using a dot triggered method. Okay, so what is the difference between these two? We don't have we don't simply have two different processes for the same task. Okay, but we have to find a difference over here. So now let's see the first one, at the rate. So we have a module TB and an event being declared, and we have the three initial begin blocks. So when we have so what is meant by an initial begin block? So the initial begin block is nothing but the block that is going to execute in the initial stage of your simulation, initial time of your simulation. Okay, so whenever your simulation starts, the initial block is nothing but the block that is going to be executed first. Okay, so since you have three initial begin blocks here, it depends on the tool whether which initial block is going to be executed first. All the three are going to be in parallel only, since they are initial blocks, but it depends on the tool. Okay, so how so which is going to be displayed, or sorry, which is going to be executed first. Okay, so let's see all the three beginning blocks now. In the first beginning block, after 20 time units, you are triggering an event and you are displaying that. And in the second beginning initial block, you are going to display the second event that your since the initial beginning, the second one is the second thread, you are telling that the thread 2 is waiting for the trigger, and you are waiting for the trigger by using at the rate of event, and you are again displaying the statement like you have the trigger has been received. And coming to the third block, the third thread, you are again displaying the this is the third thread and waiting for the trigger, and you are waiting here using another wait triggering type, like wait of event dot triggered. Okay, again you are displaying that the trigger has been received. So what will be the output of this? So once your whatever may be the order of execution of the blocks, that we don't mind here, but since we have the all the three threads being synchronized using events, okay, so we don't need to bother about the execution now. So that would be pretty much in the right order only, when you write the events in the correct manner. Okay, so in the first thread or second thread, in the third thread, in the first thread you are waiting for some event to be triggered, but in the second and third thread you are not having any wait statements, you are having only the display statements. So what are we going to see in the simulation output is the second display, the thread 2 display and the thread 3 display. Okay, because there are no any wait statements in the second and third threads, but in the first thread you have a wait statement, like the like a waiting line, which is a triggering of an event that is going to be triggered only after your 20 time units. Only after your first line executes, it goes to the second line, which is the display thread 1 has been triggered. So that is why the from the first thread you are not going to see any display statements. Okay, so now your output is going to be first the second thread display, like what is the display here, the waiting for, so thread 2 waiting for display, and then thread 3 waiting for display. And then let's consider your 20 time units has been completed. Okay, so now your event has been triggered. Once your event has been triggered, your at the rate of event A and wait of event A dot triggered, both are going to catch the trigger of the event, and your and it is going to be unblocked these the wait statements and the at the rate of event is going to be unblocked, and then the next display statements are going to be executed. So next you're going to get this display. So thread 1 got triggered, and thread 2 received the trigger. Thread 3 has received the trigger. So this is going to be your output. Okay, guys, if you want any simulation results to be shown on the screen, like it's an interactive session, if you're interested in any interactive session of these type of simulations, so you can directly ping me. We can have a discussion on it, and I can uh, make time to do that as well, so that I can easily show you the simulation results also. Even if you have any doubts of like commenting this line or that line, so what happens if I comment this line, and what happens if I don't comment that, so you can always simulate and see what happens. Okay, that's always a good practice to do. Okay, so this is going to be your output. So uh, so, but what is the difference of at the rate of event and the weight of event A dot triggered? So, since at the 20th time unit you have triggered the event, but your at the rate event, the at the rate event has been waiting from a long time. From the initial stage of the simulation, it has been waiting. Okay, since it has been waiting from the initial stage of the simulation, so this is going to catch the triggering of the event. But as soon as, well, like for example, when the event has been triggered at the 10 time units, but your at the rate statement is also happened at the 10 time units, this is not going to catch. Okay, this statement is not going to catch your trigger. So this is what the disadvantage of using at the rate of triggering statement. Okay, so this type of wait statements are the disadvantage in your events. Okay, in this place we are going to use the weight of uh, trigger dot event, weight of event dot triggered. Okay, so where this wait statement is going to be avoiding the race conditions as well. Okay, because since these both the trigger and the at the rate wait statement is going to be happened in the same simulation time, same time stamp, this wait statement can miss the trigger. So as I have already told you, when so for example, you have two initial begin end blocks, and in the first initial begin end block you have okay, I'll show you. So you have one initial block, and in the second initial block, so at 5 time units you are going to trigger the event, and in the parallel block, since it is an initial block, we are taking it as a parallel block. Okay, at 5 time units you are waiting for the event to happen. So since it is happening in the same time step, this wait may not catch, it will not catch this event. So this is what the disadvantage. But when you use this hash 5 wait of event dot trigger, so this is going to catch the event, so which is going to avoid the race conditions. So this is the advantage of using wait statements. Okay, so yeah, so coming to this example, here we are going to see the example with respect to the wait statement. So like the previous example, we have the same three initial beginning threads, but what is the difference is, yeah, so we are providing the timestamps here. So previously we haven't provided any timestamps to the wait statements, but here we are providing the timestamp. So it means that your wait event your event is being waiting for the trigger in the same time step. So as I have already mentioned you here, your at the rate is not going to work, and it is going to miss the trigger, and your the display in the third thread is going to be executed, as it is having the weight of event A dot triggered. Okay, so here the output will be first your thread 2 waiting for the trigger, and then thread 3 waiting for the trigger, and after 20 time units the thread 1 is being triggering the event, so the event A is triggered, and since your second thread is not going to catch the trigger, and your last display will be thread 3 received event A dot trigger. Okay, so this is going to be your output. I'll write here once. So thread 2 waiting for the trigger, thread 3 waiting for the trigger, so thread 1 has triggered the event. Okay, now thread 3, what is the statement? Receive the trigger, receive the event, received the trigger. Okay, so this is going to be our output. Okay, yeah, so here is the output. Wait for the trigger, wait for the trigger, and thread 1 trigger event A, and thread 3 is going to receive your trigger. So a process that waits on the triggered state always unblocks regardless of the order of wait and trigger. So so it is telling that a process that waits on the trigger state always unblocks regardless of the order of the wait and trigger. Okay, so always since you are waiting for your event to be triggered, the next lines that is being waiting will not be executed. Okay, since I have already shown in your simulations, always if you are waiting for something, it means that the next lines are not going to be executed. Okay, so so this is example for yeah, this is the same example we have been using in the like this is the new example, because we can see this also. So we have a module main, and we have two events, even E1 and E2, and we have two initial blocks. In the first initial block, we are repeating 4 times the begin and block. So we are doing we are waiting for first 20 time units, and then you are triggering the event, and you are waiting for the event in the next line and displaying the E1 trigger. And in the next initial block, you are repeating 4 times, and in the begin and block you are waiting for 20 time units, and then you are triggering the E2, and then waiting for the event to be triggered in the same time step. So as I have already told you, here your first initial begin and block is not going to be executed at all, and always your first display statement, that is event E1 is triggered, is going to be blocked for continuous simulation, as the both waiting and triggering happened in the same time step. So this is not going to be catched. Okay, so in your so your output is going to be display second display, the E2 is triggered, and since there is a repeat of 4 times, there will be a four displays repeated. All the four are same, E2 is triggered. Okay, so coming to the wait order. So okay, I think there is a typo here. So in the initial begin and block, we have in after 10 time units you are triggering A, so it's been missed here. Okay, just try just have the A over there, and in the next line you are waiting for 10 time units and you are triggering B, and then you are waiting for 10 time units and you are triggering C. So all the three A, B, C are the events that is being declared on the top, event A, B, C. And in the initial block, you are checking the order of the triggering of the statements. So you are seeing wait order of A comma B comma C, and you are checking the order of the triggering of the statements. So for example, since you have already given after 10 time units you are triggering A, and after next 10 time units you are triggering B, after next 10 time units you are triggering C. So all these are happening in the order only. So your wait order A comma B comma C is going to be successful, and your display is going to be events were executed in order. But for example, when my order is like B, C and A, but when I'm checking for the wait order of A comma B comma C, but so in this case your first display is not going to be displayed, because your wait order task or function or some subroutine is a failure, since the order has been misplaced, and your second display is going to be displayed in your simulation. So events were not executed in correct order. So this is just for checking the order of event execution. Okay, so yeah, okay, so these are for merging of events. So merging of events, as I have already mentioned in the previous slides, so assign uh, we can assign an event to another event variable like a equal to b or b equal to a. Okay, this is what we called as merging. Okay, so here we have a module event ab, and you have an event a comma b in the initial block. After one time unit you are triggering b, and then you are triggering a, and after 10 time units you are merging the events b equal to a, and then after 20 time units you are triggering a. So in the always you have two always blocks. So whenever the first always blocks is checking for the event a to be triggered, and this and it is going to display the event a is triggered, and the second always block is going to check for the event b to be triggered, and it displays the event b is triggered when there is a trigger on b. Okay, so what is the uh, uh, display statements, what is the simulation output here? So here you can I haven't displayed the timestamp, but you can do by giving uh, so we have the event a is triggered, right? So event a triggered at percentage t comma dollar time. So when you give this, you would be able to see the timestamps as well, so which gives you a clear picture of how the execution is happening. Okay, so first at time 1 unit time unit 1, your b is going to be triggered, and then in the same time unit 1 your a is going to be triggered, and then merging of events happened after 10 time units. That is where the 21 at the 21st time unit the merging of events happen, and then plus sorry, at 11 your merging happens, and at plus 20, so 31, your event a is being triggered. Okay, since your b is equal to a, when you try to trigger your b here, you could see the event a as triggered, you won't see the b to be triggered. Okay, this is what the change you could observe in the simulation. Okay, so when events are merged, the assignment only affects the execution of subsequent event control or the wait operations. If a process is blocked waiting for the event 1, when another event is assigned to the event 1, the currently waiting process shall never unblock. Okay, and we have the another example where okay, so they are telling that in the always at the rate b is waiting for the event on b before the assignment b equal to a, and this waiting always block was never unblocked. So it is telling that the second always block is always waiting for the b to be triggered. So what is the code here? We have a module event ab, and we have two events initialized a comma b, and you have an initial beginner block where after 20 time units you are triggering a, and you are merging two events b equal to a, and after 20 time units you are triggering a again over here. So what will be the output? So since you are merging b equal to a, so you don't have from now you don't have an event called b, since you are merging them, and it is going to, and both the events b and a are going to point to the same event a. So always at 20 time units you will get a display statement event a is triggered, and after 40 time units again you are going to get the same display event a is triggered. Okay, this is what going to be the output of this code. Okay, so coming to the event comparison, you can use all the equality and case equality operators. So with another event or with a null, and inequality with another event or with a null, and you have the case equality with another event or with a null operator, and the case inequality with another event or the null operator, and a test for a boolean value that shall be 0 if the event is null and 1 otherwise. Okay, all these comparison you could do with the events. Okay, so mostly, so now let's get to one point. In system Verilog, using of events can be ignored, which can be a best practice, but you should always have a knowledge of what are events in system Verilog and why are they be ignored. You would understand them when you go into a real time scenarios only. Okay, so because as I have already mentioned, there are disadvantage of two wait statements of triggering, right? So always there is a there could be a disadvantage of using these events in your system Verilog test benches. So it is best practice to avoid these events, since we have another synchronization methods like semaphores and mailboxes. Okay, so I think, yeah, events here are events gets completed, and next comes the semaphore. But as I have already told, let's complete the system Verilog test bench architecture first, and then we could go to the semaphores and mailboxes later. Okay, so now I'll show you the how the SV test bench architecture is going to be. So we have first we are going to have the test. Inside your test, you are going to have the package of your environment. Okay, so you have the package of your environment. In your environment, so you're aware of the test case, right? The test case is nothing but which is going to provide a component which is going to provide the required data that is being required to the DUT, that is going to be driven to the DUT, okay, or the design. So we have a generator, you have a generator. So when you drive the test case onto your generator is going to generate all the required values, and then you have a driver here, and we have a monitor. Okay, so your generator, as I have already told before, we use mailboxes for putting and getting of the data. So we have the mailbox. So generator is going to generate the data, and it's going to put the data into your mailbox, and your driver gets the data from the mailbox, and it is going to drive. So let's check up to here, and in the next page I'll include the DUT as well, as it is not sufficient for the place here. So the monitor. Okay, so we have on the read side, we are going to have another driver and a generator, and sorry, not generator, and you'll have the same generator is enough, but you have another mailbox here which is going to put for the second driver, and your driver is going to get, and you will have a monitor as well, and you have a reference model, and we'll have a scoreboard. Okay, okay, so suppose you have a DUT, like you have some DUT, and there are 3 signals you wanted to drive, and you have to monitor, or else we'll check, like you have three signals on the from the other driver you have to drive. Okay, there are few designs where you don't need to drive on the read side, but you just need to monitor. Okay, so we'll discuss that concept later. Let's consider you have 2 ports. The first port is having 3 inputs, and the second port is having 3 inputs. So your right side, and this is the read side. So from right side, whatever the data that you require to drive into the DUT, your generator is going to put the data into your mailbox, and from the mailbox your driver is going to take the data, and it is going to put the data onto the interface that is being connected with the DUT, which is called the virtual interface. And this virtual interface is also another concept we will be discussing in the future sessions. Okay, so when your driver takes the data and puts onto the interface, the data is being driven to the DUT. In the same way, whatever the data that is being driven from the read side also is going to be put into the mailbox, and from the mailbox your driver is going to get the data, and your driver is going to drive from the read side as well onto the virtual interface. Okay, once your data is being driven into the virtual interface, from the virtual interface itself, your monitors, both the monitors on the read side and the right side, are going to monitor the same data that is being driven. Okay, and these driven and these monitored data is being given to a reference model. Okay, so the reference model is nothing but the golden model of your DUT. It is like a Xerox copy of your DUT, but you don't have the exact RTL code. But for example, you have a 320 KB of RAM as your DUT. You don't have the same RTL over your reference model. Okay, but you will have some register type that is being declared with some some dimensions. Okay, you will have this as your dut's reference, but you're not going to have the same dut rtl code in your reference model. Okay, it's just like a copy, but you don't have the same design over there. But you're going to mimic the behavior of your dut. You're going to mimic the behavior of your dut. So once your monitor is going to monitor the data from the interfaces, and that is going to be given to the reference model. So here your dut is also working on the same data, and your reference model is also working on the same data. So now from your reference model you're going to get some output. Okay, and from your data dut also you're going to get some output that is being monitored, and this monitor data is being given to the scoreboard as well. Scoreboard is nothing but the component that is going to show you whether the test case is failed or not by comparing the two results out of your reference model and the dut. Now your scoreboard is going to compare both the outputs, and it is going to give the test pass or fail result. Okay, so for example, your from your first monitor, your driver, you have the second monitor, you have the driver. Okay, so you're driving a value of 1. Your monitor has monitored the same value 1, but your output for this 1 is going to be 0, and your monitor has been monitored that 0. Okay, now this monitored value is going to be given to your reference model. Okay, in your reference model and the scoreboard. Okay, I mean from the driver, sorry, not from the monitor. So now the same, your reference model should also give the same value 0 as the output, right? Since we are mimicking the same behavior of the dut, since your dut have given the value as 0 as the output, your reference model should also give the 0 as the output. So both zeros are being compared in your scoreboard. Now your scoreboard is going to give the result. Okay, so this is how the test case is going to be driven, or how the test bench is going to work. So this is a brief introduction on the svtb architecture. Okay, so we are going to discuss all the concepts. So here, coming to the test case, is a different concept, the generator is a different concept, the driver, the monitor or the mailboxes, the virtual interface or the reference model, the scoreboard. Okay, so all these are different concepts. Okay, but your scoreboard, the driver are the main logics that you require, because the driver is nothing but the one that drives the data into your dut with respect to the protocol, and the scoreboard should have a good comparison model that compares the output of the reference model and the dut, so that the comparison should happen in a good way. Only then you are going to get good results, right? So these are the components in your svtb architecture. Okay, we are going to discuss all these in deeper in the later coming sessions. Okay, but have these as a basic. So whenever you get a test bench, or whenever you get a design, you have to make sure you have to have that tb architecture in your mind, and that should be projected in your mind. Okay, because so that is why I have been drawing the tb architecture over here. Okay, yeah, that's all for today. I have planned to discuss only the events and the tb architecture today, so I have discussed that. And yeah, that's all for today, guys. So I'll try to put the mailboxes and semaphores also. Since I have to not waste my office time, I have been making the out of office time to make all these ppt presentations and the videos. Okay, so that is why it's being late to upload the videos, since I should not use my office time for my personal use, right? So yeah, so if you have any doubts on all these topics, you can directly message me, and you're always welcome, guys. Okay, so like, share and subscribe to my channel and support it. Thank you. Bye.